2.5 million images. One day. 40 people. That's not a typo. That's Midjourney's real ratio. The secret isn't more artists, it's a Polaroid developing out of fog. Every image starts as pure static, then sharpens into existence, step by step. Stick around, this is how AI learned to paint by learning to see through noise. Let's make that number hurt. 2.5 million images a day is 30 every single second, non-stop. A film studio needs hundreds of artists for that output. Midjourney needs 40 engineers and a GPU cluster. This ratio was mathematically impossible 5 years ago. Something fundamental changed, and it started with a failure. Before 2020, text-to-image meant GANs, two networks fighting each other. Sounds cool. In practice, notoriously unstable. Trained too long and they'd collapse, producing the same image over and over. Impressive in research papers, useless in production. Every startup that tried GANs at scale hit the exact same wall. Here's the pain point every engineer felt. GANs would train fine for days, then collapse overnight with no warning. No text understanding either. You couldn't type a prompt and get a coherent scene. Researchers needed something that degraded gracefully, not catastrophically. That something came from an unlikely place: noise. Here's what nobody tells you. The model never learns to draw. It only learns to remove noise. Every creative image is really thousands of tiny denoising guesses stacked in sequence. That sounds backwards. How do you draw a cyberpunk city by cleaning up static? Here's where it actually clicks. Training starts backwards. Take a real photo, add a little digital fog, add more. Do it 1,000 times until it's pure static, like a Polaroid left in sunlight until it's blank. The network watches every stage and memorizes exactly what each noise level looks like. Now flip the tape. Remember the fogged Polaroid? Generation runs that tape in reverse. Start with random static, ask the network to guess what noise to remove, subtract it, repeat 50 times. 50 tiny guesses later, a clean cyberpunk city emerges from fog. No brushstrokes, just noise removal, over and over again. But there's a problem. A 1024 image has 3.1 million pixel values. Running 50 denoising steps directly on that is brutally slow. Even A100 GPUs choke. If every image took a minute of compute, 2.5 million a day is flat out impossible. Midjourney needed a smaller darkroom tray. The fix: don't diffuse the full photo. Compress it first. A VAE, a compression network, shrinks that 1024 image into a tiny 128 latent. Same picture, 64 times fewer numbers. Denoising now happens in that shrunk-down tray. This one trick is why Stable Diffusion runs on a $200 GPU. 64 times fewer values means roughly 64 times faster generation, using a fraction of the memory. Because the VAE preserves perceptual detail, quality barely drops. Decompress at the end, and you get your full 1024 masterpiece back. Compression solves speed, but speed without direction is just fast noise. Direction comes from CLIP, trained on billions of image caption pairs by OpenAI. It learns to place a cyberpunk city in rain and an actual photo of one at nearly the same point in vector space. That shared point becomes the compass the denoising process follows at every single step. Inside the network, this happens through cross-attention. Image features ask questions, text embeddings answer. At every layer, neon lights and rain get injected into the exact spatial region they belong. This is how the phrase cyberpunk city literally turns into pixels, in the right place at the right time. The network doing this work is called a U-net, shaped like the letter U. It shrinks the noisy image down, extracting features at multiple scales, then expands back up, stitching in text guidance at every layer through skip connections. It's the actual hands developing our fogged Polaroid. 4 things make U-net special. Skip connections carry fine detail across the whole network. It sees features at multiple zoom levels at once. Text guidance gets injected at every layer, not just once. And critically, its output isn't the image. It's a guess at exactly which noise to remove next. Here's a weird quirk. Left alone, diffusion models produce gorgeous images that ignore your prompt half the time. The fix is classifier-free guidance. Generate twice, once with your text and once blind, then amplify the difference. That amplification is what actually forces the model to listen to you. The math is almost embarrassingly simple. Take the difference between your guided and unguided prediction, multiply by 7, add it back. That's classifier-free guidance. Midjourney exposes this directly through stylize. Low values follow your prompt literally. High values let the model get creative. Put it all together. User types a prompt, The model encodes it, initializes random noise, and runs 50 denoising steps guided by that text embedding. The clean latent gets decoded into a full image, uploaded to a CDN, and delivered back through Discord. Then you hit upscale. 5 to 15 seconds feels instant to you. Under the hood, that's 50 forward passes through a billion parameter UNet, 1 to 4 GPU seconds of raw compute. It feels like magic. It's actually just 50 very fast, very educated guesses about noise, happening one after another. Now the scale problem. 2.5 million images a day is 30 every second, continuously. Each A100 handles 8 to 16 images in parallel, taking 3 to 5 seconds per batch. Run the math and Midjourney needs roughly 15 to 30 A100s, running flat out every hour, every day. Midjourney doesn't run its own data center. It rents Linode, now Akamai Cloud, GPU clusters. Requests arrive through Discord, meaning traffic is brutally bursty. Dead quiet at 4 a.m., a wall of prompts at 9 p.m. Everything routes through a job queue before it ever touches a GPU. Here's the trap. Provision for peak, and you're burning cash on idle GPUs all night. Provision for average, and evening spikes turn into a queue nobody wants to wait behind. Midjourney solves this with dynamic autoscaling. GPUs spin up as the queue grows, and spin down as it drains. This is the same lesson every senior engineer learns eventually. Never provision for peak, provision for the queue. Batch requests together, scale compute to match real demand, let the queue smooth out the spikes. It's boring infrastructure, but it's the actual reason Midjourney stays profitable at this volume. The models kept evolving too. Midjourney V6, released in 2024, let you type full natural sentences instead of memorized keyword syntax. That's a signal they moved past plain clip, which struggles with long sentences, toward a bigger T5-style text encoder that actually understands grammar. Stability AI took a different path, open sourcing Stable Diffusion entirely in 2022, running on a 4 GB consumer GPU. That single decision spawned thousands of community fine-tunes and LoRa adapters, plus tools like ControlNet, technology Meta, Adobe, and Canva later folded straight into their own products. Scraping the internet for training data creates a legal landmine. Adobe's answer was Firefly, trained exclusively on licensed Adobe stock and public domain images. Slightly less flashy, but a Fortune 500 company can use Firefly output in an ad campaign with zero copyright exposure. That's why enterprises adopted it fast. Zoom back out. 40 engineers, roughly 30 A100 GPUs. 2.5 million images a day. That ratio only exists because every layer we covered, compression, guidance, batching, autoscaling, removes a bottleneck that would have made this mathematically impossible back in the GAN era. In your next interview, if diffusion models come up, say exactly this. It's a denoising process trained in compressed latent space, guided by clip text embeddings, with classifier-free guidance amplifying prompt adherence. One sentence. It signals you understand the architecture, not just the buzzwords. Here's the entire pipeline in one picture. Prompt goes into clip, random noise gets initialized, the UNet denoises it 50 times, guided by that text embedding. The VAE decodes the clean latent back into pixels. Every Midjourney image, every Stable Diffusion render follows this exact same path. This isn't just a Midjourney story. Stable Diffusion, DALL-E 3, Adobe Firefly, even Google Imagen, everyone runs on this same core. Noise in, denoise, guide with text, decode. Learn this pipeline once and you understand the entire generative image industry, not just one product. Remember the fog Polaroid? That's every image you've seen from Midjourney. Static, sharpened into existence, 50 guesses at a time. You can now explain diffusion models better than most candidates in a FANG interview. Subscribe for the next one, how Sora applies this same trick to video.